Find all three cube roots of 64. So our complex number here, z, is 64, and I'm going to write this as 64 cis of 0, because the angle for 64, this real number, of course, is 0. And that helps me then to use my little theorem here that my roots are r to the 1 over n times cis of the angle theta plus 360 degrees times k over n. And so now I can just kind of plug things in here. So my roots r here is, of course, 64. So my roots are going to be 64 to the 1 over 3, because I'm doing cube roots, and then cis of 0 plus 360 degrees times k, all over n, which is 3, where k can be 0, 1, or 2. Okay, so 0 up to 1 less than the number root that we're finding. And so we can go and plug those in. Plugging 0 in, we get 64 to the 1/3, which is 4. Cis of 360 over 3 is 120 times k, which is 0. 0. Okay. Then plugging 1 in, we get 4. Cis of 360 over 3 is 120 times 1 is 120. I guess I should be writing degrees here, huh? Since we're using degrees in this formula. And then finally plugging 2 in, we get 4. Cis of 360 over 3 is 120 times 2 is 240. 240. And then we just need to evaluate these. So this is 4. Cis of 0 is just 1. And then here we've got 4 times here the cosine of 120, which is negative 1/2, plus I times the sine of 120, which is root 3 over 2. And then here for cosine of 240 is negative 1/2, plus I times sine of 240 degrees is negative, I'll write that here, negative square root of 3 over 2. And of course we can simplify this a little bit. So bringing the 4 in here, we get negative 2 plus 2 root 3 I, and here we get negative 2 minus 2 root 3 I. And I'm going to go ahead and just plot these so that we can see them. If I have a circle of radius 4, okay, I've got 4. This has the same magnitude. We see 4 cis of 120. 120 is right here. And then 4 cis of 240, that's down here. Okay, so these are our 3 roots. And you can see that those 3 roots are all equidistant around this circle of radius 4. And that's always the case with our nth roots of a complex number.